Alright, time for another draftphysics.com, debatephysics.com also. And in line with the others that aren't willing to debate anything, I did a few years ago contact Kathy Loves Physics and History, politely requesting some kind of conversation on this, foundational physics and the function of the basic universe, wave particle, mv squared, that kind of stuff, and got no reply, unfortunately, and such. So she hasn't made any videos recently, which is kind of weird. So who knows? There's no comment on her channel saying why she's missing for 7 months. But who cares? Whatever. Okay, not my problem. Yeah, so we don't want to be there. We want to be here. Yeah, okay. So I just thought at first I would go over some of the reasons, some explanations of what I'm claiming. And some of it just seems, how could they miss, obvious things that are, in the real world. Even in 1850, they knew gravity existed and that the system they were analyzing wasn't some system with nothing in it besides little stuff, you know. And they already knew the matter tended to clump. So why would they argue that somehow the universe is falling apart? It just makes no sense at all. So anyway, I would argue that gravity is actually charge. And so the extension is gravity, but the elemental function is actually the charge function, and it has to do with just this simple idea that there's two kinds of force and two kinds of matter and three interactions. And with those simple formula, the fact is you create things that do exactly what you would expect charges to do, which is basically to behave a lot like magnets. So that would be the simple thing, is just to imagine electrons and protons as magnetic monopoles, and their behavior is deducible in terms of you can understand why there's not really a strong force. So it's illustrated, if these were protons, you could understand that if an electron is between two protons, you can get two protons very close together. And if I was to kick that electron out, when those two protons were very close to each other, they would now have a strong force pushing them apart. And basically, that's the game the universe is just playing. It's the only game in town is charge. Alright, so we'll get back to this after I do some drawing, I guess. Alright, so much of the Claudius and such people who invented this theory of entropy, and especially the second law, indicating that somehow everything tends to fall apart, is because they're thinking of some closed little box, and you have a bunch of stuff inside the box, and you're just basically saying that if let's see, the stuff will like say if it was just a random bunch of pixels of different colors, that there's some possibility that it will draw a picture of Bugs Bunny, but there's very unlikely that you're going to get that one arrangement to pop out of this system over even almost an infinite amount of time. It's like the ink flowing back into the ejector. The odds of even getting one molecule to go that high speed would be astronomical. To get all the molecules to do it at the same time would be insanely unlikely as an event. But if you just reduce the system to, say, 3 objects or 6 objects, where you have, 4 blue, one color, and then 4 of another color, and you mix those, well, obviously now you have a much higher probability of all the reds being on one side and all the greens being on the other side. And it'll happen, whatever, 1 in 50 or whatever, 1 unit of time out of 100, it will have all the greens on one side, all the reds on the other side. And so you can understand that it's, this is a probability thing, and this has nothing to do with the original definition of entropy, all right, which was just about how heat flows. And the obvious kind of argument is that obviously heat, from our perspective, there's nothing hotter that we know of technically than like suns, and they produce energy, but frankly it's a tiny amount of energy compared to how much energy they have. And the whole point is why they have so much energy is because they've gotten matter consolidated. And what is matter? It's atoms. And what are atoms? Well, atoms are actually things created in high pressure suns by smashing electrons and protons very close to each other. So you could argue in 1850 they didn't have a good description of the idea of an electron and a proton being the elemental players. But even without that idea, they still saw, the universe and saw how gravity works. And the fact is, there was nothing stopping Earth from being created in the universe. It seems a perfectly one of the functions the universe has. So, unlike this box of, just heated molecules that they were both basically thinking about, our universe has other functions that are causing effects inside of here. And the key function is, big G, gravity. And as I will argue, that function is really just about putting the monopoles of the electron and the proton, the magnetic monopoles, in arrangements. And so you could sort of understand that when you do put them in this arrangement, that what will take place is that you'll end up with stuff very close to each other that doesn't necessarily like each other. So you could argue that a stacked magnet, if you could do something to break one of these, change one of these electrons into a proton, that the whole thing would fly apart because all of the bonding energies wouldn't be balanced anymore. Where if you stack them properly, organize them, the fact is you can put them in a very small space. So something like a neutron star would be the material idealization. I don't think there's black holes, but whatever. So a neutron star would basically be all the electrons and protons in a very tight arrangement inside of matter, and much like magnets stacked. And so you've taken the magnets and negated their oppression by keeping them in a balanced relationship between their positives and negatives. So the repulsive elements are further away from each other than the attractive elements, and therefore the attractive force overwhelms the repulsive force and it stays together. And so the simple argument I'm making is that that's what gravity creates. By creating high pressure, it creates these things called neutrons, which would just be one of these simple dipoles. And so a neutron star could just be understood as a bunch of these pairs, these dipoles, arranged very compactly. And that's what stars are creating, is neutrons first. The fact that it ends up being helium in the end, doesn't have anything to do with what I think the pressure's first doing. Anyway, so it's building nucleuses, and it's building them this elemental piece at a time, the neutron. All right, so it's taking hydrogen atoms basically and compressing them, creating a neutron. So you can make it that simple. And the reason why the sun is hydrogen, I would argue, is mostly because it is so hot and compressed that it breaks everything else. So it's in the process of melting and disintegrating just as many atoms as it's making. And so it has its own equilibrium. But regardless, you don't even need to think that to understand the point. Okay. And the simple point is you could understand that the energy is a consequence of places where you have one of these arrangements of an electron and a proton and an electron, or a proton and an electron and an electron, you have one of these arrangements, and all you have to do to understand that you're going to create a lot of energy is to hit this one out quickly, and then you'll end up with two protons that hate each other and will at a very high velocity repel. So it's just like you're flipping one of the monopoles in the structure, and it'll just disrupt the structure. It'll have to get out because it can't stay in the structure. All right, because the structure is balanced, and any change will create an imbalance. So that's kind of the simple argument of why the sun's radiating energy, is because it used no energy essentially to, it's not like it's using energy to create this arrangement. It's just that the arrangement innately is created by the high pressure, because it just kind of squeezes the things together. Kind of just forces that event to take place because of their natural attraction. So it's not a strong force, it's a weak force, in the sense that all you need to do is put them under enough pressure where they're close enough to each other where they'll find the fact that they can stick together. They can flip and stick, and that's really what you're after. Right. So you can understand that the energy is really in the fact that the magnet connects very easily, so it's anti-entropy. The real elemental force is magnetic, and magnets stick to each other very well, and they're very hard to pull apart. And so you need high energy to break essentially the dipole of a neutron, for example. And once you've done that, the consequence is that you might have ended up with two protons that are way too close to each other. And the fact that, I guess you really should I mean, the simple diagram is that if I have a proton and an electron next to each other, what's really happening, because there's two elements of force, is that any green force that goes into the red comes out red, and then it goes into the green and comes out green. So it doesn't do anything to create momentum. So all of the green force going this way is inert, and all of the red force going this way. The red force going this way just ends up coming out red without doing any work, and any green force that goes in this way, goes right through without doing any work, without moving anything, giving anything momentum. And that's really what you're taking advantage of in terms of being able to push these things together. Because a third object, if I put a green here, it's going to repel here because it's all reflections, and it's going to attract here because of this idea that half the force can't be seen by the objects, and so they're only being affected by one half of the energy. The green thing, basically it's green, it's reflecting all green. The red's reflecting all red, so there's no opposing forces. There's no same force to push on anything, so they attract. All right. Yeah, well, that'll do as a preface, I guess. Just pointing out that the elemental the electron and proton aren't in gravity. They're in this field that they interpret by creating this phenomenon of charge. So charge is the elemental function, and then it ends up being gravitational, just because the fact that bigger objects, atoms, I have to I have to point out how the atoms aren't. All right, I have to think about that. All right, I remembered how to say it. So once you have atoms and you have all these electrons and protons inside the atoms, why they're attractive to each other is because you have to understand that it's really their motion, and their motion means the electrons and protons are moving. So if an atom's moving, it means that everything inside of it is moving. Okay, all the electrons, all the protons have to have that momentum in whatever direction the atom is moving. And because the function of the matter is that I pointed out there's a reflection, but there's also, the fact is the force sticks. And so if an electron is moving, it's because it's collected force. No, like this. Yes, it's collected it. And that's the only way it can move, is that it has to have captured force, which means that force isn't going where it would have been if it hadn't been captured. So you can understand that any motion means that there's less force getting to a destination, and any motion this way. So when the Earth is moving things into each other, creating this pressure, it means there's a bunch of force trapped that hasn't gotten where it would have been if it wasn't moving matter. It moves the matter much slower than the speed of light. Depending on how much force has been collected, obviously. So the more force something collects, the closer it gets to its original speed, and essentially then there's less gravity. If the electrons and protons, if I could move my hand at the speed of light, it wouldn't be creating any gravity, because I wouldn't be absorbing any energy and changing. I wouldn't be changing the universe any. The force would have gotten to its destination at the same speed, but I can't move it that fast. So there's always going to be some gravity. Because of the slowness of matter, you could argue, maybe it's 10%. A force bit hits and the matter moves. The question is, does it move 1/100th of the speed of light per force bit, or is it some other number, like 1/10? Anyway, open question. But anyways, the absorption, its motion is a representation. Motion of an object means that the object has collected energy that would have been somewhere else, and that's the point of it. And so that's what's creating the gravity, is the motion. So there's a bunch of motion in objects that have gravity. And you could argue that that's made obvious by the fact that the inside of the Earth is molten. It's kind of just demonstrating that there's all that motion has been created by the matter moving. The matter is moving because there's a bunch of force that it has collected. It's felt more force in one direction than it felt in another direction, and it's moving in the direction where there was more force, in the direction of it's moving in the direction of less pressure, because it has collected more pressure. So here's the Earth, you're here. The idea is the energy can't get through the Earth without hitting a bunch of atoms. When it does, electrons and protons, when it does that, it pushes some of them. The fact that it's pushing them means the force isn't going to get to you here, and you're pulled in because the force on the outside is still pushing you quite regularly, and the force from the other side hasn't gotten to you because it's pushing pieces of matter inside the Earth. So I'm going down into the Earth because something else on the other side has collected energy, now has momentum, and is moving in the opposite direction. All right. So that's how charge leads to gravity. All right. Now the bigger subject is why in these 1850s weren't these people appreciating that the system, they keep talking about a closed system, that the system of the universe itself has these functions in it, and most glaringly the function of gravity, which constantly performs the opposite of entropy, which is it's constantly crushing things and not spreading things, not mixing. It actually is filtering. It is organizing electrons and protons. Alright, so leave us play some of the video and I'll just make the point. Gravity, 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 gravity. And just say, why the hell aren't they recognizing that the universe as a system has this obvious function in it that is doing something exactly the opposite, okay, of spreading stuff. It's converging stuff.
Occurring during any change of condition whatever can only be positive, or, as an extreme case, equal to nothing. In other words, entropy of a closed system can only increase. And that's not all.
So, so the obvious argument is closed system with what? No functions in it. So they're just talking about a closed system with one mechanism governing it. And if there's any other mechanisms, of course, the entropy can be broken by that other mechanism. So it's just, the argument is so empty in terms of not recognizing that the universe has charge and magnetism and gravity and all these other functions in it. And there's no reason to think those functions aren't doing the exact opposite of entropy or breaking apart. They're obviously pushing things together.
Way back in 1862, some 50 years before Walther Nernst produced it, he came up with the third law of thermodynamics too, writing, quote, "It may be proved to be impossible practically to arrive at the absolute zero of temperature by any alteration of the condition of a body." 3 years later,
So yeah, that's a kind of a complex way of describing the third law, I guess. But anyway, you know, it doesn't mean anything because, again, the third law doesn't mean anything in the context of gravity, because the idea of achieving an absolute temperature would be to imply that there's no gravity causing things to move inside of gravitational objects. So you have to annihilate gravity to say you have absolute zero. And obviously absolute zero, as the idea of temperature, just means that, okay, there's no photons, there's no radiation we understand hitting the object, but if you understand gravity must be also a form of radiation, that it isn't just a bent space, because it does create momentum, it does create movement. So I'm just saying you can't have absolute zero when you know, like put the Earth, just take that as an example, this big heavy object. So if you concede my point that the Earth is molten because of the gravity, because a bunch of stuff has momentum towards its center, and its center is very hot because there's momentum going both ways, and it's doing a lot of this jiggling stuff. If you concede that argument, you'd have to concede that every small object is doing the same thing. It's just that the temperature is much lower. But the fact is it's happening, that it's electrons and protons are still being moved by gravity. Now, obviously, I'm arguing it's being moved by charge, but I'm just saying you can't get rid of that charge field or the gravity field or whatever you want to call the fact that there has to be this force that has the speed of light momentum, and that speed of light force has to be annihilated from the universe for you to be able to achieve a temperature of zero. Yeah, fact.
1865, Clausius published his 9th paper on heat. In this one, he said he was motivated by the desire to, quote, "bring the second fundamental theorem, which is much more difficult to understand than the first, to its simplest and at the same time most general form."
And again, the simplification is you've just annihilated all functions. So you have to have a box where there's no functions, except for the fact that things have motion and they can change their vector of direction. So you have a box and you have BBs in it and they're all going one speed and they're bouncing off walls. Well, okay, and you put a dot on one of them. Okay, and you can make some argument about how it, put dots on 3 of them, how that chaos is very unlikely to create a pattern of the three dots together, let's just say. But the very fact that it will at some point do that means that this argument is kind of defeated by the argument that you could make that even if you're going to use this silly mixing argument, if you were to convert that into the energy argument, which is again they're two separate subjects, mixing and the evolution of energy, they're two separate subjects. But even if you were to play that game and say, in this mixed form, it's very unlikely. Well, very unlikely doesn't mean it doesn't happen. And so you could argue that every time those three things stick together in a clump, that would be a recharging of a battery. And now you could run the system again for another million years because you did this thing that recharges the battery. So even if you're going to say it's unlikely, if the unlikely event charges the battery, then you've already created a system that's sustainable. So all you need is one function that in some way recharges the battery. And obviously gravity recharges batteries.
This paper is mostly important for the new terminology in it, because this is the paper where he renamed the equivalence value to be the shorter term entropy and gave it the letter S, for no reason I can tell. We still use the letter S for entropy because of Clausius.
Right, but we don't use his formula. We use the other guy's, who's doing the random thing. So it's really not the same subject. What started it, okay, and what it became, they're two fundamentally different arguments about two fundamentally different processes. So again, I'm simply arguing that energy doesn't abhor consolidation. It consolidates just as easily as it falls apart. It's just as easy to build a star as it is to blow one up. All you're doing is a tiny change in its magnetic condition, and you've achieved the task of creating something that's flying apart versus something that's stuck together.
Clausius said that he picked the term entropy from the Greek word for transformation, and he, quote, intentionally formed the word entropy so as to be as similar as possible to the word energy.
So it's not all energy would be closer. So anyway, it's hard to say what to say about that. So obviously, they're trying to imply this is about energy when it's really not, because energy in the universe is about moving matter, and just look at where the matter is in the universe, right? So if I was to say, let's figure out where all the electrons and protons are in the universe, the answer is going to be that 99.9999999999999% of them are in one of those stars or planets. That's where it all is. It's all in a clump. It's not spread out over the universe, quite obviously. So it seems kind of ridiculous to argue that there's some tendency to declump when there seems to be some obvious tendency to clump.
Clausius then concluded with his version of the two laws of thermodynamics. 1, the energy of the universe is constant.
So this is, again, old news. So, that was argued back in the 1600s and before, that there seems to be some cycle to the whole thing, like the water cycle or the carbon cycle or some other cycle, that it all seems quite cyclical and that energy is never lost in the universe. It's just always traveling somewhere else. But again, the irony is, the fact is, so there's no mention of gravity in any of these conversations, so they're clearly not considering the universe with the function of gravity in it. They're considering some universe that doesn't have gravity in it. And the big flaw of the gravity theory is that obviously gravity gives things momentum. It gives material objects momentum. They crash into something and then they radiate radiation, something like a photon. And so you have to figure out, well, how did it create that photon? You used a bent space to create momentum. It made a photon. Isn't that generating free energy? That's breaking the cycle, frankly, unless you're going to argue that somehow the gravity is the radiation. Then you've completed your cycle. So if you understand that there are photons we can't see, okay, and that clearly that's the mechanism. Photons we can't see pushed the object and gave it momentum, and it made photons that we can see. That's not a problem.
And 2, the entropy of the universe tends to a maximum.
So why would they say that? The entropy of the universe tends to a maximum. Why would they make a claim about the entire universe which isn't some it isn't a system with no functions? It's clearly a complicated system with some functions. At minimum, the function of charge and magnetism. 2 huge functions. And then you add, what I would say is gravity as a consequence of those 2 functions. So why would that, it's just such a... And in none of their conversation are they talking about any galaxies or they don't even know of the existence of galaxies. They're not talking about stars and planets and solar systems and gravity and every indication that the solar system is more like a collapsing system than an expanding system. It seems quite obvious that it was very cluttered and it became very uncluttered.
Clausius's version of
the point is that their own understanding of how a solar system had already had a diagram of it as being something that condensed. It wasn't something that it's now expanding. It was something contracting, and that all, 1 million or 2 million years ago. Is that what I want to say? 200 million? Yeah, 1 billion years ago. Okay, or 4 billion years ago, let's say. There was a bunch of stuff. Okay, and all that stuff consolidated into the winners, the things that had the right path with the right momentum. And those right paths ended up collecting all the rest that was there that didn't end up falling into the sun. But that's the truth of it. It had a very high entropy, and it consolidated into very low entropy. I mean, I don't even know why I have to make these arguments. So you're saying to me this is somehow the smarter physics is to make this bold assertion about how the universe functions where you totally ignore all of the systems in the universe? I don't think so.
The 2 laws of thermodynamics that he wrote down in 1865 are still considered correct today.
For no good logical reason should anybody consider them correct, especially when you've seen a galaxy, especially when you understand the solar system and you've seen the craters and you understand how the thing must have worked. There's no reason to believe that axiom, dogma, frankly, that complete misperception of the reality.
Meanwhile, William Thomson, one of Clausius's big critics, was working on his own version of the second law of thermodynamics, albeit one without an equation.
So, yes, fine, yes, and you don't, because an equation would be ridiculous. So, yes, Lord Kelvin, known for his mathematical prowess, wasn't really fooled into thinking you could actually measure this mushy definition of something called an entropy.
Before, in 1852, Thomson wrote that there was always a waste of mechanical energy available to man.
Right, so he's making a counter-argument to Claudius and the original guy, that we're sort of assuming that energy was unrecoverable. And he's basically saying, well, no, it is recoverable. And so it's probably worth reading some of this other stuff. There is an absolute waste of mechanical energy available to man when heat is allowed to pass from one body to another at a lower temperature. So you can collect it. By any means not fulfilling his criterion of a perfect thermodynamic engine established on a new foundation in the dynamical theory of heat. But see, this is the problem. As it is most certain that creative powers alone can either call into existence or annihilate mechanical energy, so some reference to God, the waste referred to cannot be annihilation. So in some ways he's saying you can't kill the heat, you can't kill the energy, but must be in some transformation of energy. Okay, so he's just saying it's there. And frankly, the point I would argue is that, yes, it's always transformable. To explain the nature of the transformation, it is convenient in the first place to divide stores of mechanical energy into two classes. Well, that we don't need. Okay, statistical and dynamical. Now, that's just going to create confusion. So yeah, we'll read the next thing he wrote, which is more interesting.
When heat is allowed to pass from one body to another at a lower temperature. By 1862, Thomson declared that the second great law of thermodynamics involves a certain principle of irreversible action in nature. It is thus shown that, although mechanical energy is indestructible, there is a universal tendency to its dissipation, which produces a gradual augmentation and diffusion of heat, cessation of motion, and exhaustion of potential energy through the material universe.
Okay, so he's making the assertion that, yes, the universe is going to die of some heat death. But it doesn't make any sense, because the concession is that you can always make something colder. You can always create a tap to pull heat. So why would they think the heat is unrecoverable? All right, the result would be inevitable be a state of universal rest and death. If the universe were finite and left to obey existing laws, And so what law is the law of gravitation? One of the existing laws? I mean, I can't state it any clearer, but where they think this heat goes. If I throw something into space, what's the odds that it's never going to hit anything? Well, I'd argue they're kind of long. It's going to push a piece of matter. But it is impossible to conceive a limit to the extent of matter in the universe. So he's saying the very thing. He's saying he can't imagine the limit. So why wouldn't you think that any bit of heat that's out there is going to hit something, and when it hits something, it's going to push on it, just like you're saying, it's going to do work. And when it does that work, it's going to create something that has motion. And now you've put the energy back into something big. You've taken the heat and converted it into material motion. I mean motion in one direction, let's say. You've converted it back into something that can cause heat. All right. And therefore, science points rather to an endless process through an endless space. So now he's implying that, it's saying it seems like it can't stop because it looks like there's too much of a system for it to ever entropize. Yeah. Of action involving transformation of potential energy into palpable motion and therefore into heat and then into a single finite mechanism. So he's saying that the finite mechanism, goes from heat into what he was thinking of something like infrared radiation. And the whole point is the radiation is itself still momentum. And the radiation will hit objects and push them. And the odds are it's going to push them into something else. Gravity. Okay. running down the clock and stopping forever. It is also impossible to conceive either the beginning or the continuance of life without an overruling creative power. So again, a reference to God. And therefore no conclusions of dynamical science regarding the future condition of the earth can be held to give dispiriting view as to the destiny of the race of intelligent beings by which it is at present inhabited. So he's saying we don't know what the destiny is, because maybe God will save the day. But I mean, just the whole argument, again, there's just nothing in here indicating that, well, quite obviously there's a function in the universe called gravity that seems quite capable of absorbing radiant energy and converting it into big object motion. I'm just saying they knew they could collect heat, and they knew it's just harder to collect when it's there's less of a differential. But it's not like it's impossible to collect. And why would they think the universe can't collect it?
With entropy, Clausius had given the irreversible action of nature an equation and a name. But wait, you say, or maybe you say, heat over temperature is not the equation I learned for entropy. That's probably because you and I were taught Boltzmann's entropy equation.
Right, which is more of a probability equation about mixing, not about dispersion.
Won't be surprised to learn from its name that Clausius did not create Boltzmann's entropy equation. But you might be surprised to learn that Boltzmann didn't create it either. Even though...
Alright, so we won't bother with this. This is her next video. So again, just confusing two subjects. Mixing stuff and the idea of energy dissipating into smaller and smaller forms into some finite form that is uncollectible. That's their argument. The second law is basically saying that energy degrades into a form that's uncollectible, when I would argue that just like the sunlight from the sun, we're collecting it right now, it's creating momentum, part of the earth is being pushed, and sunlight is a little bit of a pushing force, and it's just a fact. That's all. Just it is a fact that the energy is going back into the motion of bigger atoms and molecules. Convection. There's so many places where you can see it in action. So anyway, probably enough. I'll think for a moment and see if there's anything else I need to say. Alright, I guess the bottom line is this is just another poorly articulated axiom that got shoved into physics, and physics won't let go of it. So, like mv squared, an unevidenced statement about reality. This is an unevidenced statement of reality. I mean, just the simple examples. If I throw a bunch of little magnets into space, what are they going to do? Well, they're going to flip and crash into each other. Okay, they're not going to show any desire to mix or to entropize or to do any of that crap. They're going to do exactly the opposite. And if I just throw a bunch of molecules into space, okay, in a field where they're not going to be sensing something else's gravity to any large extent, you could watch gravity work, okay, but it's going to be slow process compared to the magnets. But it's going to happen, okay? Newton knew it was going to happen. Newton calculated it happening. And you're almost saying, well, 100 years later, these guys are saying, it's not even 100, it's 200 years later. 200 years later, they're not paying any attention to what Newton says happens in the universe. And you're just saying, well, that doesn't make any sense. How can that make sense? They're not paying any attention to, all the reasons why Newton got some right answers about how things move in the universe. And they do this stuff where they're inevitable. Their tendency is to clump. Their tendency is not to fall apart. It's to do exactly the opposite. And you'd almost think there was no mechanism blowing them apart if we didn't know about supernovas and other events, cosmic ray bursts and stuff. Otherwise, the universe looks like all it's doing is clumping and creating a little tiny bit of sunlight. Alright, anyway. So, till the next time, and such, and so forth, and whatnot. Enough of a video, I think. So, I'm not forcing you to watch these videos. I think the subject is interesting because, again, it just shows that they say things, and because a Lord did it, we're all supposed to be forced to believe it. And, but what was the reasoning? And my argument simply is when they said the word universe, they weren't visualizing a universe that has any of the functions that our universe has in it, namely charge and magnetism, because those two things give no indication of entropy being a one-way street.